Today we're pushing Flutter to its limits by building a fully animated solar system. This animation will feature rotating planets, orbiting moons, and a glowing sun, all running smoothly using Flutter's CustomPainter, matrix transformations, and AnimationController. First, let's create a new Flutter project. Once the project is ready, open it in VS Code, navigate to main.dart, and set up a basic structure of Material app. Create a new file named SolarSystemScreen.dart. Inside this file, first we're importing the necessary libraries. Dart Math Import gives us access to mathematical functions like cosine and sine, which are essential for calculating the orbital paths of the planets. And of course, we're using the Material.dart package, which provides all the Flutter widgets and tools we need to build our UI. Now let's create a Solar System Painter class to draw and animate planets dynamically. In Flutter, whenever you want to draw something really custom, something beyond the standard widgets like buttons or text, you often use something called CustomPainter. Think of CustomPainter as your personal canvas and brush set in Flutter. This Solar System Painter is inheriting from CustomPainter, meaning it's going to handle all the nitty-gritty drawing for our solar system. Inside Solar System Painter, the time variable is absolutely crucial for animation. It's going to be the driving force that makes our planets move. As time changes, the positions of the planets will change, creating the animation effect. Next up, we have the Solar System Painter constructor. We must provide a time value to use this class. Now, the heart of our drawing is the paint method. This is where all the magic happens. Flutter calls this paint method whenever it needs to redraw our solar system. It gives us two important things, a canvas and a size. The canvas is exactly what it sounds like, our drawing surface. It's like a blank sheet of paper where we can draw lines, circles, shapes, whatever we want. The size tells us the dimensions of the area we have to draw in. Basically, how big our paper is. Inside Paint, the first thing we do is find the center of our canvas. This center point will be the center of our solar system, where the sun will reside and around which all the planets will orbit. Offset in Flutter just represents a point, defined by an X and Y coordinate. Then we create something called Orbit Paint. Paint in Flutter is like your brush. It defines how things will be drawn, its color, style, thickness, and much more. Here, Orbit Paint is set up to draw the orbits of the planets. We give it a color of white, but with some transparency using alpha, 0.7. Alpha controls the transparency, with 1 being fully opaque and 0 being fully transparent. Painting style.stroke means we're only drawing the outline of the circles, not filling them in. Alright, now we start drawing. The canvas.drawCircle draws our first orbit. DrawCircle is a method on the canvas that draws a circle. It needs 3 things: the center point, the radius, which is 70 here, and the paint to use, Orbit Paint. We do this 3 times with radius of 70, 140, and 200 to create 3 concentric orbits for Venus, Earth, and Mars respectively. Next, we're drawing the sun. We first define the sun's position, which is right at the center of our canvas. Then we create sun paint. This time, instead of just a solid color, we're using a radial gradient. A gradient is a smooth transition between colors. A radial gradient specifically radiates outwards from a center point, like the light from the sun. We set the colors to transition from colors.yellow accent to colors.transparent. This makes the center of the sun appear bright yellow, fading out to transparent at the edges, giving it a glowing effect. Stops defines where these colors stop in the gradient progression. 0.3 means at 30% of the radius from the center, we are at colors.yellow accent, and by 1.0, 100% of the radius, we are at colors.transparent. Create Shader actually creates the shader and applies it within a circle defined by rect from circle. Finally, canvas.drawCircle draws the sun using this fancy gradient paint with a radius of 90. Now let's get to the planets. We start with Venus. Venus orbit radius sets how far Venus is from the sun, which is the radius of its orbit. Then comes the interesting part, Venus X and Venus Y. This is using trigonometry to calculate the position of Venus as it moves in a circle around the sun. Let's break this down. Cosine and sine are trigonometric functions. When you change the angle from 0 to 2 pi, or 360 degrees, cosine and sine traces out a circle of radius 1 centered at 0, 0. We're using time into 3 as the angle. As time increases, this angle changes and Venus moves around in its orbit. Multiplying time by 3, Here just makes Venus orbit faster than Earth and Mars, which we'll see in a moment. Multiplying the Venus orbit radius with cosine and sine scale up that unit circle to the size of Venus's orbit, which has a radius of Venus orbit radius. We add center.dx and center.dy to shift the center of this circle from the origin, 0, 0. So Venus orbits around the Sun in the middle of the screen. This Venus paint creates a simple orange paint for Venus, and canvas.drawCircle draws Venus as an orange circle with a radius of 15 at its calculated Venus X, Venus Y position. We do something very similar for Earth. Earth orbit radius equals 140 is its orbit radius. Earth X and Earth Y calculate Earth's position using time directly, making it orbit slower than Venus. For Earth's appearance, we use a radial gradient again, this time transitioning from colors.blue accent to colors.transparent, giving Earth a bluish glow, and stops are set to 0.5, and 1 means the blue color extends further out compared to the Sun's yellow in its gradient. Canvas.drawCircle draws Earth with radius 25. Now for the Moon. The Moon orbits Earth, not directly the Sun. So, its position calculation is a bit different. Moon orbit radius equals 30 is the Moon's orbit radius around Earth. Notice we are using Earth X and Earth Y as the center for the Moon's orbit, meaning the Moon orbits around Earth's position. Time into 2 makes the Moon orbit a bit faster than Earth around the Sun. We use another radial gradient for the Moon, from colors.white to colors.transparent, with stops set to 0.3 and 1, giving it a white lunar glow. Canvas.drawCircle draws the Moon with radius 15. Lastly, we draw Mars. We set the Mars orbit radius to 200. It orbits with time into 2, slightly slower than Venus around the Sun. Mars paint creates a simple red paint, and canvas.drawCircle draws Mars as a red circle with radius 10. That's all the drawing inside the paint method. The should repaint method at the end is important for performance. Flutter calls this method to decide if it needs to redraw the custom paint again. Returning true always tells Flutter to repaint whenever Solar System Painter is used, which is what we want for animation because we need to redraw with every new time value to update planet positions. Okay, that's the Solar System Painter class. Now let's bring this solar system to life by animating planetary motion. The Solar System Screen widget is where we set up the animation. We use a stateful widget because we need to manage the animation state. Inside the Solar System Screen state, we use a single TickerProvider state mixin. This mixin is essential for creating animations in Flutter using AnimationController. Think of TickerProvider as a source of clock ticks that drive our animation forward smoothly. Single TickerProvider state mixin is used when you need only one animation controller in your state, which is our case. Inside the state class, we declare AnimationController. AnimationController is what controls the animation. It manages the animation's progression over time, lets us start, stop, reverse, and repeat animations. In a init state, which is called when the state is first created, we initialize our controller. We set the animation duration to 10 seconds. VSync, this is crucial. It connects the animation controller to the widget tree's refresh rate using this, which is our solar system screen state. This ensures the animation is smooth and synchronized with the screen's refresh rate, avoiding janky animations. Repeat at the end starts the animation and makes it loop continuously. So, after 10 seconds, it will start over from the beginning, creating an endless animation. In dispose, which is called when the state is about to be destroyed, we have controller.dispose. It's super important to dispose of the animation controller when you no longer need it to release resources and prevent memory leaks. Finally, the build method is what actually builds the widget tree for our screen. We create a basic screen structure with a black background, which is perfect for a space theme. Inside the scaffold, we have Animated Builder. This widget rebuilds whenever the animation controller's value changes. Animated Builder is a very efficient widget for animations. It rebuilds only the part of the widget tree that depends on the animation value, not the whole screen, making it performant. Animation property set to controller tells Animated Builder which animation to listen to. The builder function gets called every time the animation value changes, on every tick of our animation controller. Inside the builder, we return Custom Paint widget. This is where we actually draw our solar system. Here we are using our Solar System Painter. We create an instance of Solar System Painter and pass in the value of the time property. Controller.value is the current progress of the animation, which goes from 0.0 to 1.0 over the animation duration, 10 seconds in our case. We multiply controller.value by 2π because cosine and sine functions in Dart, and generally in trigonometry, work in radians, and a full circle is 2π radians. So, as controller.value goes from 0 to 1, time goes from 0 to 2π, making a full orbit for planets that use time directly in their position calculations. For Venus and Mars, that use time into 3 and time into 2 respectively, they complete 3 and 2 orbits in the same animation cycle of 0 to 2π for time. Size set to size.infinite tells CustomPaint to take up as much space as possible within its parent, filling the entire screen in this case. And that's it. This code creates a beautiful solar system animation with orbiting planets and a glowing sun. You can tweak the orbit radius, speeds, colors, and sizes to customize your own little solar system. You can even add more planets. Have fun experimenting. Want to learn more Flutter animations? Check out other Flutter animation videos on this channel. Also, drop a comment below and let me know what animation you'd love to see next. Until next time, keep fluttering.